Okay. Hi, everyone. My name is Kennedy Cole, and I'm the Outreach Coordinator for the Center for Urban and Regional Analysis at The Ohio State University. I'm excited to welcome you to our second webinar in the series From GIS to GeoAI, Bridging the Gap in Geospatial Education. This series is co-sponsored by CURA, the Ohio State University Department of Geography, and the University Libraries Research Commons. Throughout this series, educators from across the country will talk about their experiences teaching GeoAI to the next generation of geospatial professionals and discuss what it means to be AI fluent in the context of geographic information science. Today, Eric Shook will discuss his work in using AI to design, develop, and deploy next generation curricula in GIS science, geospatial computing, and geospatial data science. Before we introduce Eric, I want to mention a few logistical items. If you required closed captioning today, you'll find a box at the bottom of the screen labeled with CC. Click the box and select Show Subtitles. This will allow you to view subtitles during the presentation. During the webinar, feel free to submit questions at any time using the Q&A box. We'll ask as many of your questions as we can in the last portion of the presentation, and if we do not get to your question, apologies in advance. Chat has been disabled, so please use the Q&A if you have any information to share with the organizers. As you may have seen on our website, this event is approved for one AICP CM credit. To claim your CM credits, log into your My APA account on the APA website and enter the event into your online CM event log. There will be a brief survey at the end of this webinar. If you have time, we encourage you to provide your feedback to improve these events. If you have any additional questions following this event, don't hesitate to email cura@osu.edu. To learn more about Cura's future events or sign up for our monthly newsletter, visit cura.osu.edu. You can learn more about the Research Commons at library.osu.edu/researchcommons and the Geography Department at geography.osu.edu. Now, I'd like to turn things over to Josh Savari, the Geospatial Information Librarian at The Ohio State University Libraries, who will introduce our speaker.
Thanks, Kennedy. I'm very excited to introduce today's speaker, whose efforts to advance GIScience pedagogy and curriculum development I've long admired from afar. Eric Shook is an associate professor at the University of Minnesota, where he works at the intersection of geography and computer science. He's the co-lead for education and workforce development for the NSF-supported I-GUIDE project, as well as the director of the GeoCommons and Spatial Makerspace, which are collaborative hubs for geospatial research, education, and public engagement at the University of Minnesota. His research combines geographic information science and computational science in the field of geospatial computing. Eric also focuses on advancing geospatial education by integrating advanced technologies such as AI into the curriculum development process. And I think that's what we're going to be hearing about today. So I'll go ahead and turn it over to you, Eric. Thanks.
Oh, well, thank you for the kind introduction. So, yeah, today we're going to be talking about the intersection of geospatial sciences, AI, and curriculum. So the big question, of course, is AI, artificial intelligence. Why is it such a topic of discussion for universities, science, society? One of the reasons is something that we call scaling laws and the speed at which AI is advancing, either in its capabilities or its problem solving. There's several different definitions. And this is similar to if you were growing up and experiencing the 90s and you bought a computer, you installed some software on your computer, and you maybe played a game, you maybe, used a piece of software for a while, and then 18 months later, you buy a new computer, you move the software and the games over to the new computer. Instantaneously, everything that ran on that computer is twice as fast as the old computers. So this is how computing technology operated throughout the 90s, and now it's less so for a variety of reasons, but this is kind of an example of the scaling laws. And if we take a conservative estimate of AI advancement, where the capabilities of AI are doubling roughly every year, what we can do is use an analogy that I told a whole bunch of undergraduate students here at the University of Minnesota. when they were admitted to the U and they were debating on whether or not they should join campus. So they had some professors explain things. Mine was AI in education. And I used the following example that, if we're talking about spring semester that just wrapped up, and we're in the Ford Model T era where the top speed of, 35, 40 miles an hour, right? That's going to be kind of today or, a month or two ago. By the time they would get on campus, you'd not be driving 40 miles an hour, you'd be driving 65. And then you go through your first freshman year, you come back as a sophomore, and now suddenly everybody's driving 130 miles an hour. Then 260, 520. By the time you graduate and you step foot into your first real job, everyone around you is going 1,000 miles an hour. So the challenge with scaling laws and the reason why everyone is looking at AI and trying to make sense of what's going on is we're living in a 40-mile-an-hour world, trying to understand how to teach, how to educate, how to train, how to prepare the next generation for maybe 1,000 miles an hour, which has a huge impact in terms of understanding what are the rules of the road when you're traveling that fast at the speed of a fighter jet. So this is one of the big reasons why people are talking about AI. Now, of course, we might hit some laws of diminishing returns so that we don't actually hit 1,000 miles an hour, but this is kind of one of the motivations for why this could be so impactful. So, when we're talking about AI and curriculum and education, a lot of students, as bright young minds, just see it as one more piece of the education puzzle, along with their readings, lectures, maybe they watch some videos. In our world of GIScience, they'll be exposed to maps, and then we add AI on top of it. On the flip side, the way that I look at this kind of cloud is we have kind of three big pieces. We have the current piece, which is our current curriculum, the geospatial curriculum, which are the existing knowledge and skills that we're hoping to impart on students who join our university. We then have a second circle of Geo AI curriculum. These are going to be new knowledge and skills where we're using AI with geospatial approaches. And this is kind of a new category of things that students need to be exposed to and gain knowledge and skills. Then we have a box on top of both of those, which are just AI technologies in general. So these might not be geospatial. They might be large language models, LLMs, multimodal models where you could combine text with images. They could be AI and something called agentic systems, where you build AI agents that can do more complicated things using things like tools. So this is kind of the way that we can break this apart. And what I'm going to do is kind of give a little bit of background so that we all kind of understand, what it is that I'm talking about. And you can hopefully walk away with at least a high level understanding of how AI technologies can get incorporated into curriculum building, curriculum review, and the education process itself. I'll share a couple of projects that are either ongoing or in the pilot stage. And then I have kind of a couple of open up kind of prompts to help the Q&A session. So this is what we're going to be doing today. And this is just my perspective. And as Josh mentioned, I'm an associate professor in the Department of Geography and Environment Society at the University of Minnesota. I direct a new space that we built called the GeoCommons and the Spatial Makerspace. I co-direct our professional master's program in GIScience, and I'm co-lead of education and workforce development for a National Science Foundation Institute project called I-GUIDE. So I wear several different hats when we're talking about curriculum and education. So I'll be kind of exploring what we're doing in each of these categories throughout the presentation. Starting with GeoCommons, which is actually a physical space. So it's a lab space where we were able to redesign, rebuild to create a collaborative hub where we get to combine research, education, and public engagement. And it is kind of a fun space that I like to say is that we invite everyone from middle school to mid-career. We've had mid-career workshops. We've had lots of middle schoolers, K-12 students, educators of K-12 students, as well as obviously undergraduate, graduate students, staff, and faculty. So we were really fortunate to have our second visit by the Board of Regents. They just visited the GeoCommons and Spatial Makerspace a month ago. So we were really fortunate to have our students host them, show off some of the projects, including robots, boats, educational projects, maps, the whole nine yards. So the students did phenomenal. It was just really exciting. And the reason why I show this is AI actually enabled some of these students to move forward with pretty ambitious projects that would have been much more difficult even just a couple of years ago. So I think that we already see a lot of the impact and the potential of using AI in education when it's literally just put in the hands of students, where they're using it to empower their own learning rather than trying to empower our instruction. So I already am a big believer in it, and I'm happy to answer questions once we get to the Q&A as to how I tackle all of it. But to start, I want to talk a little bit about how we traditionally build curriculum. I've been involved in a number of projects where we're developing educational materials, curriculum, shared syllabi, and these sorts of things. So I just wanted to give a little bit of a recap as to kind of how the things have been done. And then we'll talk about how I think at least things will happen moving forward. And when I say the word curriculum, I'm talking about a systematic plan of instruction designed to guide learning in a subject or across subjects. And if that's too complicated because it's a Friday afternoon, just think of it as a roadmap for instruction, right? So it just kind of helps guide our instruction in a systematic way. A big piece of this puzzle for GIScience is actually the UCGIS GIS&T body of knowledge. This is a amazing achievement by the field, 414 topics, crossing 10 knowledge areas made by, hundreds of scholars. This is an important piece of a curriculum because it provides a kind of holistic understanding of the field, and we can then build on top of this. I played a very small role in the BOK, but it let me understand how some of these bigger, more complicated things operate. I was fortunate to go to Switzerland for a couple of years, and I was part of a group where we were trying to build GeoAI syllabi, and then we tried to get some funding, and then things got a little complicated for a variety of reasons. So this was really focused on capacity building in GeoAI, and this was kind of a unique experience looking globally at how we could potentially spread the way that we would teach GeoAI at different levels. I also lead the development of what we call the convergence curriculum for geospatial data science, which is part of the big NSF funded I-GUIDE project. This is a multi-year, multi-person collaborative curriculum building process, starting with listening sessions across multiple scientific domains, an iterative process for building, and the design of this curriculum is to support what we call multiple learner pathways. So we designed a modular and flexible curriculum system and model so that different individuals coming from different backgrounds could mix and match and fill kind of educational and training gaps where they would have them. So a computer scientist might need more kind of training and education in geospatial and probably less in computing. And then a GI scientist, probably vice versa. So this has been public and available. I have a number of talks kind of covering the details of this. And, the point of this is to kind of do just-in-time education and training to bring people up to GeoAI, geospatial data science, so that we can solve convergent problems as part of the project. Earlier, before this, and what kind of fed into the convergence curriculum, I was PI of a project called Hour of Cyber Infrastructure, where we developed 17 interactive problem-based lessons that cover foundational concepts and introduce core skills. So we had a beginner and intermediate lesson of all 8 of those topic areas. That was a wonderful collaboration with Karen, Forrest, and Anand. We had weekly meetings. This also went over the pandemic, so it holds a special kind of space in my heart. And really, what we were trying to do overall, kind of big picture, was to develop best practices that guided the development of lessons. The lessons would teach cyber literacy to our learner community. Embedded within the lessons, we had assessments. So cyber literacy was tested by the assessments in the lessons themselves. And then we were able to gather some data to improve the lessons and the best practices. So it created this kind of this wonderful feedback loop. Now, the reason why I'm bringing this up and why I set up kind of the traditional curriculum building is this is where I think AI and curriculum and education is going to head. Because I think where we're at right now is we're working on developing best practices for incorporating AI into the educational process from top to bottom. Those best practices will then guide the development of new curriculum material in the form of lessons, exercises, labs, et cetera, et cetera. We will then teach those lessons, in AI, Geo AI, or other topics with AI as part of the experience of the learner. And then we're going to do some assessments, both in terms of how that impacts learning, what the experience is for the learners, and that provides data to then feed back into best practices. So with AI, we're actually in this exact same kind of positive feedback loop where we're learning along with our learners. And I think it's really important to point this out because I think a lot of people are looking for, what do I need to do now? Which might give you a little bit of information, but that might be different than what you need to do in the future because we're still in the process of working on this. But we've been doing this for a while, so we have a little bit of practice in terms of how we can do these things. And the difference here is that AI just accelerates the rate of change. And a little bit more on that in a second. I also actually went down to middle school. I created and taught a middle school elective class where that was called Exploring Geospatial Technologies. We talked high level science in kids, talked about digital twins, geo AI, and photogrammetry. This is the bottom right image is a 3D model of a cardboard town that the kids built, and then they used photogrammetry techniques to make a digital representation. It was first time they'd ever done it, and they did a phenomenal job. And that was an exciting endeavor. So we've, kind of been doing lots of different education. We've been doing lots of trainings, and this is kind of the traditional way that we do it, which is to say that you have somebody who's an author, right? And what they're going to do is produce some educational content and materials. That could be slides, readings, in my world, code snippets or Jupyter and computational notebooks, might be lab exercise tutorials, etc. Then that content goes to a reviewer that kind of look it over and make sure that it meets some sort of, decent specification, try to, smooth out some rough edges and things like that. And you might do a cycle of that with the author. Then ultimately it goes to some approver where they decide, okay, this has met, some level of a quality bar. It, achieves learning objectives, what have you. And then that content gets published. Now, these 3 roles, author, reviewer, approver, might be the same person. So for example, if you're an instructor of a class, you might author the content, review the content that you just authored, and then ultimately approve it and put it up on Canvas or your learning management system. So it's not to say that, these have to be 3 separate human beings. But these are kind of like the three big rules that generally you do when you're working on kind of collaborative curriculum development. And this kind of introduces the ability to do AI. So that was a long lead up, kind of trying to talk about where the disruptions are going to be and trying to kind of lay a foundation so that people can understand what I'm talking about once we get to this step, because this is where things start to shift and change, and sometimes people get a little uncomfortable. So this is kind of our human loop, right? We just covered this: author, reviewer, approver. Just kind of a feedback cycle. And now what we're going to do is show different renditions of where AI can be inserted just in the curriculum development process. So first off, we can have what's called human in the loop. And here, what we're doing is using AI to author the material, but you still have a human reviewer and approver. So the example of this would be using, ChatGPT, Anthropic Claude, Google Gemini, and you prompt it to generate a lab exercise for you, right? You then review the lab exercise, you decide it's good enough, and then you publish it in your class. So this is kind of what we call human in the loop. And importantly, at the end of this, we have AI created content because AI was the original author of the material. We can also have human in the loop where AI serves as the reviewer. And in this case, what you would do is take existing material that you made as the author, you upload it to a AI system, and you have the AI review it, looking for, gaps, holes, have it do some sort of a curriculum review. And then you can iterate over that, and ultimately you would approve it as a human, but we have human created content in this case. We can replace one more step, and we can have AI be both the author and the reviewer, including a feedback loop where you have the author author something, the reviewer gives feedback, the author improves, goes back to the reviewer, ultimately going to a human as an approver. Here again, we have AI created content. We also can do something slightly different, which is called human on the loop. Here, what we're doing is using the human as usually an additional reviewer that watches and oversees the process of improvement. The difference here is that AI is both authoring the material as well as approving when it's done. So usually in human on the loop, what you would have is some sort of done or finished criteria that the AI approver will actually look for. So it will have, a set of objectives or quality criteria that once the AI author has reached, then the AI approves it and it moves forward, right? So that's what we call human on the loop. And then we can say human out of the loop or fully autonomous, where AI is authoring, AI is reviewing, and AI is approving. So at this point, there's no human in this process at all, right? You are basically handing over the autonomy for AI to guide the curriculum building process entirely. So these are kind of some of the options that we're talking about. And now what I want to do is go through a few examples across those different hats that I wear in terms of different roles, and seeing where we're putting AI and how we're trying to evaluate it, trying to understand what the capabilities are, and looking into the future. So starting with the I-GUIDE project, we are looking at AI agent curriculum building using an agentic system. And the current focus for us right now in I-GUIDE is doing what we would call human in the loop using human approval. So we're not going fully autonomous for I-GUIDE. We will have a team behind it, making sure that anything that's AI generated meets a quality spec. And what we're doing right now is actually experimenting with how is it that we can improve this process, where AI is both the author and the reviewer, in order to make consistent quality curriculum material that can be used, so that hopefully we go through this process and it's basically ready for approval. We don't have to go back to the drawing board multiple times. And then, of course, there's always going to be this process where that curriculum goes out and actually gets, implemented and taught, and people actually learn from it. And then that kind of guides um, our process for improvement of the workflow in the agentic system. And, the overall goal of all of this, of everything that I'm talking about today, is really to kind of improve learning for the learner, as well as I'm a firm believer in this, and happy to talk about it during the Q&A session, but accelerate learning. I think that with AI, we can actually not only help the kind of the depth and the quality of learning, and kind of building more competencies in our learners, but I think we can also accelerate and speed up the learning process. So this is kind of one of the bigger goals. In order to make this accessible, beyond just me and a few people who have computational backgrounds, what we're trying to do is actually build out the entire system from beginning interface to the system itself to any sort of products that are available to educators and scientists around the world. And that way, everybody can kind of understand how in US terms, how the sausage was made, right? You can actually go in and you can look at the code, you can replicate the process, you get to play with the interface, and everything is well documented and clear. That comes at a cost that I'll talk about in just a second, but we have kind of a prototype interface where a instructor can give topics. We can upload a template for the agentic system to follow. It gives a preview that allows for iteration, and then we can generate not only PowerPoint, but also video, because throughout this process, when we're generating slides, it also generates the lecture notes. So what we can do is then automatically create audio using text to speech. And then we can create a video narration where you have the slide, you have the audio automatically narrated with the lecture notes with perfect synchronization, and then you generate a video. So especially when we're talking about the new, well, the now delayed ADA requirements, this gives us a powerful way of making sure that all of our materials are accessible, because we'll have the perfect caption that matches the speech. So this is kind of one potential improvement that we could do. Um, but of course, this is a little bit of an experiment right now, because we don't have a solid understanding today, let alone into the future, where the pitfalls are for AI and where the strong potential is for AI. And what do I mean by that? When we're talking about authoring and reviewing using AI, we have to give it some kind of suggestions as to what and how we want it to author those curriculum material. We also have some limitations currently with AI in terms of what it can produce. So the content type, right? Whether you consider it slides, whether you consider it readings, whether you consider it lab exercises using code, for example. We also have differences in capability in terms of the content length. So if you ask an AI agent right now, or an AI system right now, generate a 15-week course, uh, it will very much struggle with that. At the same time, if you ask it to make a 15-minute lesson, the frontier models do a phenomenal job, right? So we have this gradient in terms of the content length that current LLMs can handle. Then, of course, the review process, we don't have a solid way right now to guide AIs so that the review process is consistent, especially for geospatial, where we have our own set of kind of domain expertise that we want to apply and to use to review. As well as the production process, where we have some guidance in terms of what we're looking for and these sorts of things. So for I-GUIDE, this is actually what we're working on over summer. So these are open research questions that we're looking at exploring, and we've built up an experimental framework in order to look at that and to hopefully improve and to provide some guidance. And our starting base is what we call the Agentic Workflow Builder. And the whole idea is basically to replicate the process that I just showed with the traditional way. And what we've done is broken up the AI system, the agentic system, if we use the jargon. And what we do is we feed in, I'm calling it content right here, but you could think of it as topic and a little primer as to, what you're trying to teach or what you would like the lesson to focus on. And then we basically break it up into a series of steps so that we can experiment with what happens at each step and how that affects kind of the quality and the consistency of the materials that are created at the very end. And what we do is we take that content, we send it to a brainstormer that comes up with lots of ideas. And then those ideas get sent to a writer. The writer produces a first draft of the curriculum material that then gets sent out for review, which is very similar to how we do it for the convergence curriculum. We have a geospatial reviewer, we have a computer scientist reviewer, and an educational reviewer. These reviewers are AI, by the way. They're just prompted to act as though they have geospatial backgrounds. Those reviews come back and are all cobbled together to an editor. An editor looks at all three reviews, just like a traditional editor, make some suggestions in terms of what they would like to see changed, which then gets sent to a reviser to revise the original lesson based off of the reviewer comments and the editor comments. We then send it to a copywriter, which is, again, these are all AI. So the AI cleans up our copy, the text, looks for jargon, different things. And then we have AI created content. Now, the big question here is this the right workflow? Do we have the right pieces? And how do we break this apart so that we can improve quality and consistency? The second piece is which AI models do we use? So we can use frontier models all the way through, but what we're finding is that some of these stages can actually use smaller models, which are cheaper, faster, and would then make it a little bit more accessible for people to use. And eventually it would be nice to be able to run this locally in case if people don't want to use cloud-based systems, although then you kind of lose access to the bigger frontier models. So what we're doing right now is trying to keep it pretty accessible. Everything here is available on the I-GUIDE platform. So the code that I was just talking about is available. You can get the prompts, you can get the agentic kind of workflow that I have a screenshot here. And we're not using any super advanced features. We're trying to keep it pretty accessible so that people can see it, people can understand how it works, and people can apply it without a whole bunch of technical requirements, right? So you can kind of see this is a little bit of an example as to if you looked at the code, what you would see in some of the output. We are at a bit of a crossroads, and one of the things that I just mentioned is that the current version is accessible because we really built to help people understand how you can use these agentic systems to build curriculum so it's replicable. The question is, our next version that we're building over the summer, should we build it to be more advanced so that it's more capable but harder to understand? Or do we keep it accessible for understanding? So I leave that as a potential question for feedback. And if anybody has any thoughts, feel free to jump in at the end or send me an email because we need to make that decision very soon. So that's one example of creating curriculum using AI. As part of our master's program, we actually also created a curriculum review system using AI. And a shout out to Dan Goldberg from the last UC GIS meeting, who was really trying to push this at his institution. So uh, I came up with a slightly different rendition that we can use that kind of connects to the UC GIS body of knowledge. And for those of you who don't have background in this, because I assume that we have kind of a broad audience, and it's not just GISers like me. UCGIS is the University Consortium for Geographic Information Science. It's basically, the big group of people who do GI science research and education, primarily in the US, but it's growing increasingly international. And the body of knowledge has 10 big knowledge areas. This kind of encompasses everything that the field has to offer. Those are broken up into over 50 subtopics. And then those are then decomposed into right now 414 kind of topic entities. Asking people to go through and review their courses in their curriculum across 50 subtopics or 414 entries is just a little bit too big of an ask. So what we did was used AI to regroup these subtopics into 20 topic groups. Each topic group has 2 to 4 subtopics, and we can then assign a topic group a rating of 0 to 3. 0 meaning, this course doesn't touch this topic group at all. It introduces competencies at the introductory level, moderate, or in-depth is basically how that it works. And what we're trying to do and iterating over is testing both AI and human reviewers so that we can have good iterator reliability so that whether you're using AI, right now we're using Google Gemini because University of Minnesota is a Google shop, and that's what our university policies today says that we can do. And a human, right? So this is kind of what we're doing. And just to give an example of what we're talking about, this is 3 knowledge areas with a set of subtopics. And this is how we have arranged them into topic groups. So the dashed orange box in the middle is the new stuff that we were doing. And we have 20 of these topic groups. And then you can see off to the right, you can see foundations and context in analytics and modeling contains methodological context, building blocks, and analysis of errors and uncertainty. So we kind of group those subtopics together. This is still, I would say, moderately early. We still have a couple of bugs to smooth out, but it's definitely, I would say, promising as a way of actually doing curriculum review, which is really, really hard because it's really hard to get people to do this tedious work. So it's been very rewarding to be able to at least have a first cut as to what the topic coverage is for our professional master's program across our entire body of knowledge of the field. So this is kind of a promising area that eliminates some of the tediousness of doing curriculum review. This isn't a completely overwhelming slide. I provide it as the human interface using spreadsheets. What we ask people to do this same rating. So off to the left, we have the review matrix. We ask people to put in their ratings 0 to 3. We have the rating guide that describes what does a 3 mean, what are you looking for. If you see this, then don't rate it a 3, our exclusion criteria. And this is what actually goes into the AI system as well. So we're giving the exact same instructions to humans as well as AI. And what we're trying to do is kind of change and modify the description syllabus evidence and the exclusion criteria so that we're getting the same ratings on both sides. So this is kind of the overview of what we're doing there. So another, useful, I think, kind of way of helping us understand where our curriculum actually is situated, especially as things move, because it's time intensive. So if you're only doing it every so many years, but the technology and the field is advancing faster than that, it's nice to at least be able to do more current updates. And kind of the last piece that I decided to add last minute, so I apologize to the captioner. I appreciate the manual captioning that Ohio State University is doing. And this is some pilot research that we're doing as part of GeoCommons and my research really kind of testing the waters of what AI is going to be capable of doing and what we can actually pull away from using AI. And one of them is it's actually live. So I have the link below and I'll share slide links. So everything's available and clickable. Um, I was in a meeting where we were talking about creating these GeoAI playbooks, one for decision makers that are oftentimes busy and don't need to know the technical details of GeoAI, but need to know what is it that they need to understand about either GeoAI capabilities or what they're seeing as output from GeoAI. And then GeoAI kind of a training for the people who are either working with the models, using the models, building the models. And the key that I made in a panel presentation was these two things need to be in sync. So the leadership needs to be able to provide guidance and best practices for the operations, and the operations needs to actually align with the goals of the leadership. And the tediousness there is just the separation of those two things and developing something that stays in sync. So what I did here was actually use Claude Code, and this is entirely AI generated. So this is basically what we would consider almost autonomous. I was prompting it for some additions and everything else, but I wanted to test the waters to see what would happen. And this is definitely not perfect. If you look at it, there's some gaps, there's some different aspects to it that I would like to change. However, if you compare it to what existed before and what was going to be built in the next couple of years, we either have this, which is imperfect, or we have quite literally nothing. The reason why I say nothing is that I actually deprioritized this and I didn't have time to build it myself. And I think it's important when we're talking about AI is a lot of the time the comparison is my best work or the best work of the best instructor for education and AI. And oftentimes, especially when you're talking about education, educators tend to be incredibly busy people, especially if you're talking about K-12, but university professors, I'll toss us in this bucket too for a little bit of empathy. It's actually really, really hard and time consuming to build good educational material. And oftentimes the question isn't my best work and AI, it's I have no time or AI. So I just want to put that out there that as you're looking at this one, especially, it's kind of a live pilot. This probably was never going to exist. So the fact that I was able to get it this far using kind of minimal time is really promising and allows us to kind of open up the possibility for other things, especially as my calendar starts to open up now that we hit summer. And then I just want to do a really quick sneak peek, and then we'll open it up for questions. This is something that I was really grappling with the last couple of talks is um, usually when I talk about kind of AI and education, there's usually a first level question of, what's the difference? Or are we going to be replaced as, teachers, educators, instructors? And I've really grappled with this question because it's hard to answer in any sort of a systematic way. And here I actually use Claude Code to help develop a taxonomy of the learning process that consists of 6 layers. There's like 50 definitions where we start with literally what's the definition of a person? What is a thing? What is an action? What is information? And then we build up the next layer, the next layer, the next layer, the next layer, all the way to layer 6 of the learning process, which includes an instructor, what is a lesson, what is mastery. And each of the definitions of instructor, lesson, mastery build on the lower layers. So we have a internally consistent definition set that we can start looking at and then have a fair way to differentiate what is a human teacher and what is it that AI is doing in terms of instruction. And using that taxonomy, where we're at right now, we're on version 10, using prompting with AI and me manually editing. I actually have hard copy right here at my desk that I manually edit, go back and come back. A teacher is an instructor who's a person, right? I've underlined person, expresses understanding, reasoning, knowledge, or belief that all have definitions and demonstrates skill. This is an important differentiator that AI, until we get to robotics, really can't do to a learner. Wayfinder, which is the fun name that I gave to the AI, is an instructor that's an automated system, right? This is where we're starting to get into uh, computing, and it systematically adapts instruction in response to a learner's demonstrations or assessments, right? So that's how we're differentiating, at least in this taxonomy, in this version, the difference. So this has been really interesting because it has allowed me to do the next step, which is to start looking at models. And this one's kind of borrowed from computer science. And this is a very pre-publication sneak peek of how do we actually understand what's going to happen if AI improves the quality and kind of the speed of learning? What's actually attainable for learners if they're accelerated or have some sort of an educational benefit from AI? And I can go into this, but basically, I hypothesize that right now, most learners are actually what we would call instruction bound, meaning that they could actually learn more if we as instructors were better for their learning context. Meaning that if we could adapt our instruction individually to those learners, they could learn better and faster. And I think generally most instructors would generally say that that's true. It just doesn't scale. There's literature behind it. There's, the Two Sigma from Bloom's that kind of talks about this. But what's interesting is that as you start solving the instruction bound, you'll eventually hit a capacity bound from the learner. And really what we're trying to do is find those ridge points. And these are going to be different for different learners under different topics, under different scenarios. So this gives us a way of actually starting to really abstract out what is it that we're talking about using very exact definitions. So this is something that, again, pre-publication, we're still drafting and working on, but hopefully we'll get out this summer. And this just kind of primes me for the Q&A. I like this Hemingway quote of from The Sun Also Rises, and Bill asks, how do you go bankrupt? And he goes, two ways, Mike: gradually and then suddenly. And I think that this is kind of where we're at with AI. I think that we're gonna not see progress. Everyone complains that it's terrible, and then suddenly it's good enough, and it really takes off. So I don't know exactly where we're at on that, what they call kind of hockey stick curve, but I think that this could apply. And one of the challenging things that we'll run into, just as a food for thought for you going into Friday, is many of us in the workplace are familiar with something that's called salary inversion, where newer employees actually are hired at a higher salary than more senior employees that have been established. It's possible with AI improving curriculum as well as learning that we're going to have a capability inversion at universities where newer students might learn more than the senior ones. And that is going to cause all sorts of interesting problems for us, but just something to think about, because generally we have seniority means more capability, more competence, but that might not always be true with this acceleration. It might also explain some of the grade inflation problems, but that's a different thing. And then the last thing is just basically caution with traditions. And I have this kind of example where we start with something like I'm proposing here with an AI solution, and then that becomes practice. The practice becomes a standard in the field, right? The standard then becomes the tradition. The world changes, things advance, whatever. The tradition remains, but it's not actually a solution anymore. So I think that this is one of the things that us as educators, especially in a particular domain, have to watch out for. And it's really difficult to disentangle, is a tradition worth keeping? Because it gets into all sorts of politics. So we have to pay attention to that as we're going through this big change. And the last thing that I'll say is, with AI, I think the analogy that I'll use is uh, that we live very much in an excavator world. And the challenge for us as educators when we're starting to incorporate AI, geo AI, is knowing when to put down the shovel, right? Because the students are going to have excavators and they need to learn how to use excavators, which is a different thing than digging dirt with a shovel. And it's not necessarily just to go faster, which is one of the things that I said, but to have them dig deeper, right? So one of the things that acceleration allows us to do is actually to get farther in the education process and build deeper competencies is really kind of the goal. So this is just something food for thought for everyone as we go into it. And I have to thank, so many people for all the wonderful support and agencies and everything else. And with that, I just want to thank everyone for their time. I realize I'm a native Midwesterner and I talk really fast, but happy to answer any questions that you might have.
Yeah, thank you, Eric. We have some really great questions in the Q&A, so I'll turn it over to Kennedy in a couple minutes. But before I do, there's definitely one that I wanted to ask you about the first example that you talked about in sort of integrating AI into your curriculum development, the idea of sort of uh, feeding it a topic and having it produce lessons and videos and transcripts. And my question in that one is, can you talk a little bit about maybe either your current practice or your thoughts on, is this a situation where the corpus that this material is being created from is the entirety of the training data for a particular model, where it's not necessarily as apparent what those training data are and who created those training data, versus maybe a more personalized option where you could say, well, as an instructor, here's all the curriculum I've developed recently for my courses over the course of the last few years, or here's the body of knowledge, or here are some openly licensed textbooks in the area that I'm interested in. And then you're controlling and narrowing the corpus from which these materials are being created. So what are you currently doing, and maybe what are your thoughts on those different kinds of approaches?
No, that's a fantastic question. So, right now we are not doing any sort of big differentiation where we feed it only a small set of curriculum material and openly licensed data, and we're mostly testing either local models, meaning that we're running an AI model on a machine that we own, either a server or desktop or something like that that usually has GPUs. Or we're using the cloud-based services through right now for I-GUIDE, we're using Microsoft Azure because it's under the university license umbrella, so that it allows us to do this type of work. Or we've experimented with a couple of different models because Azure allows us to do ChatGPT and everything else. I do think that there is interesting room to, especially for ethical reasons, control which model we use and how that model was trained, which I think kind of goes to your point to some degree, of making sure that we're using material that is properly licensed and everything else. There is a trade-off though, because the frontier models like do a phenomenal job compared to pretty much anything that I've seen so far locally. Everybody says that there's a lag, but for me, for educational material, the lag is bigger than what you might see online, from other people saying like that there's a 6-month lag. In terms of adapting for local curriculum, I think that that's a huge benefit, especially for geospatial. So we like to have, uh, very local examples. So one of the nice things is if you have a generic curriculum that says, I want to teach GeoAI, and the example is, University of Minnesota, but you have a local curriculum from that's not GeoAI, but is maybe some spatial analytics, that focuses on Ohio. What a lot of frontier models will be able to do is actually take that example and take that context and move it over and turn a GeoAI example from Minnesota to Ohio. And I think that that has a huge value for learners because, they tend to be a little more invested when it's local. At least that's been our experience, if that makes sense.
Yeah, thank you. I have a lot more questions. I'm going to pick your brain at UCGIS in a couple of weeks, but I'm going to
Yeah,
turn it
yeah,
over.
yeah.
I'm going to turn it over to Kennedy now to get into some of the audience questions.
Yeah, thank you so much, Eric, for the amazing presentation. We do have a handful of questions. Sorry to those who I'm not going to be able to answer your question. Please feel free to reach out, though, if you still want to get your question answered. I'm sure Eric would be willing to do so. Um, Someone asked, this is still in the early stages, but is your team looking into how using AI-enabled curriculum impacts people socially, economically, psychologically, and their physical environment?
Yeah, it's an interesting question. So, I will say right now, we are not looking at the people side. And the reason why we're not looking at the people side is that then triggers IRB, which, is a whole set of paperwork. It's not necessarily that it's not important, but it would basically make us have to pause what we're doing so that we can then create the right structure to be able to study that specific piece. So I think that, my answer right there for that part is no. Physical environment is an interesting question because that actually overlaps a little bit with GeoCommons. And one of the things that we actually talk about in class with students at the University of Minnesota is having the availability of the technologies and how that actually shifts what's even possible for learning. So one of the motivations for GeoCommons was to actually get, all the technology in the hands of students, and staff and faculty. So in that way, the physical environment is really shifting things because we had students, building robots that had zero robots or electronics experience. And the only way that that works is by being embedded in a physical environment where that's possible and the encouragement and kind of the tools to be able to do it. So I think it's an interesting question, but no, we haven't been looking fully on the psychology side. We've had some discussions in class on the social economics piece for sure. But no, it's an interesting question. I'll take that back and think about it a little bit more.
Okay, great. Okay, so I have time for one more question and then I'll send it to Josh to wrap us up. Someone asked, I expect there will always be wrong or somewhat incorrect information, although likely in smaller degrees. How are hallucinations handled in this context? Can AI review itself and flag things that maybe not be 100% true, or to point out the human reviewer that they should take a look at certain sections?
Uh, yeah, so also great question. So I would say yes. AI can catch a lot of issues. Now, I'm pausing at hallucinations just because it's very, specific target. So I'll just say anything that's incorrect, right? Anything that you don't want as a curriculum, whether that's a hallucination, meaning that it made something up, or it's just off base, which isn't necessarily a hallucination. The AI review process, especially when you give it very clear criteria, has been increasingly wonderful. And on top of that, not only the review itself in terms of topic, one of the things that I found to be really valuable for the review process is giving different perspectives. So you can prompt it and say, I'm a, student who has this, and this, or my learning style, or my background, or my learning context is this, and this. How would I interpret it? And while it's not necessarily perfect, I think it goes to the second part of pointing out to the human reviewer what you should look at. So it can just, raise some flags to say, oh, this might, not fall very well as an analogy, or you're going to lose people in this midsection because the jargon is too much. So on that side, especially the latest models are doing great.
Right. Great. Well, thank you, Eric. Josh, you want to close us out?
Yeah, just again, thank you so much, Eric, for today's presentation. Some really interesting things for us all to consider, and thanks to everyone for attending. Our next webinar in the GIS to GeoAI series is Friday, July 24th from 12 to 1 p.m. Eastern. The next month's talk is titled Preparing the GeoAI Workforce, Lessons from Research and Teaching with Wenwen Lee, Professor of Geospatial Data Science in the School of Geographical Sciences and Urban Planning at Arizona State University, where she directs the Spatial Analysis Research Center, or SPARC. So thanks again, everyone. We hope to see you next month as well, and have a great weekend.
Thank you for the invitation.